Hello everyone, this is Mrs. Lindsay. Today we're going to review vertical and horizontal asymptotes to help us with sketching some graphs. So let's again review asymptotes, which we did in the beginning of the year as well. We'll start with vertical asymptotes. So we have the line x equals a is a vertical asymptote of the graph if either the limit as x approaches a from the positive or the right side of a function goes to positive or negative infinity, or if the limit as x approaches a from the left side of the function is positive or negative infinity as well. So if we take a look at these examples here, we want to evaluate the limit. Now this is kind of hard to see in this one, the first one. That is as x approaches 2 from the right, and the bottom one is as x approaches 2 from the left. Okay, so you can see we have the actual picture of our function here. This is our graph of the function. 1 over the quantity x minus 2, that's what we have graphed here. So you can see that we have a vertical asymptote at 2. So again, the vertical asymptote is at 2. We want to evaluate the limits of these. So as it approaches 2 from both the right-hand side and the left-hand side, from the right-hand side, again, it's going towards 2. And as it approaches from the left-hand side, these are going to positive and negative infinity. Okay. So let's try a few of these different examples. So vertical asymptotes, are you dividing by 0, and can the problem be removed? So hopefully you remember when you're dealing with vertical asymptotes come from the domain where the function is undefined. So we have our two examples here. We'll deal with the one on the left first. Y equals the quantity y1 minus x over the quantity 2x squared minus 5x minus 3. So dividing by 0. This is where we're going to start with working with our vertical asymptotes, okay? Now please realize too, I'm going to go back to the previous example here. This only comes into play if you're valuing the limit at the number where, again, this number as x approaches 2 from the right and the left is where actually the vertical asymptote is occurring. So again, if this was another value that we were finding the limit, we still go through our process of direct substitution and our other rules if those don't work as well. Okay. So again, we're finding the vertical asymptotes here. So we're going to take the denominator, 2x squared minus 5x minus 3. If we set that equal to 0, we will find the values that are undefined. So in this case, we'll factor that. That'll be 2x and x. Now again, we're doing our guess and check method here. Factors of negative 3 can go in these two spots. So it's either going to be negative 3 and 1 or 3 and negative 1. So I want to take 2 times 3 because I know that's going to get me close. That'll give me 6. I'll make it negative 6. And then if I add that to 1x, that gives me negative 5x. So again, I'm checking my outer and my inner terms to come up with the middle term. And then the first 2 terms multiply to the first term. The last 2 terms multiply to be the last term. Okay. So I set each one of these equal to 0. So x is negative 1/2 and x is 3. Now, if you recall, though, these are the values that it can't equal. This is what will make the denominator equal to 0. So both of these will be vertical asymptotes. Neither one of these can be removed because if I take my factored form, 2x plus 1 times the quantity x minus 3, and I put it back into the original problem, nothing can cancel out. So nothing can be, as our question stated up here, nothing can be removed. So both of these, x equals 3 and x equals negative 1/2, are our vertical asymptotes. So let's try our next problem. So again, let's factor. Let's go ahead and factor both the top and bottom. Instead of separating it out, I'll just do it and leave it within our problem here. So in the numerator, I'll take out an x. It's the GCF. In the bottom, we'll factor as well. So leading coefficient here is just 1, so it would be just x and x. Factors of -2 that add up to -1. -2 and +1. So in this case, when we set both factors equal to 0 in the denominator, we get 2 and we get -1. However, let's go back to our question up here. Can any, oops, sorry about that. Can these be removed? Well, unlike our previous problem, we can reduce. That is a removable discontinuity, which in other words we would call, and it comes from this factor of x minus 2, we would call this a hole, not a vertical asymptote. So in this case, x plus 1 could not be removed, so x equals -1 is our only vertical asymptote. Okay. And let's go ahead and go a little bit further. I know the question didn't ask you for this, but how would we actually find the ordered pair of that whole? Well, we know x is 2. To find the y value, we plug that into the reduced form of our function. So I would plug in x equals 2 into x over the quantity x plus 1, so I'd get 2/3 for my y value. So that is the location of where the hole would be located. Okay, so that's vertical asymptotes. Let's go ahead and move on to horizontal asymptotes, and again reviewing this from earlier in the year. The line y equals b is a horizontal asymptote of the graph of a function if either the limit as it approaches infinity or even negative infinity, so both of these, positive infinity or negative infinity, of the function approaches a value b. Alright, so again, what is happening here with these horizontal asymptotes? What is happening as it goes to positive or negative infinity? What is the end behavior as we look at our graphs? And there's 3 situations that you reviewed from pre-calculus as well as the beginning of the year. If it's bottom heavy, so in other words, we're looking at the degrees of the numerator and the denominator. So if it's bottom heavy, it's 0. So in other words, we would call the horizontal asymptote is the equation y equals 0. Top heavy, it would be some sort of infinity, plus or minus infinity, or none. Alright, there would actually be, if we were talking about a limit, we would say there is none, does not exist. If it's even heavy, it's the lead coefficient. So in other words, the equation there would be y equals a over b, where a and b are the coefficients of our degree term. Okay. So again, this is a review from beginning of the year when we were talking about limits. So let's take a look at a few examples in terms of horizontal asymptotes. So we have 3 examples here. We're going to determine the horizontal asymptotes of the following equations here. Okay. So in the first case here, we're going to look for the leading coefficients. So in other words, the degree term. So in this case, careful of the order. This is the degree term of the numerator, and this is the only term in the denominator, so that would be the degree term as well. So we have degrees, numerator is 3, degree in the denominator is 1, so this is going to be top heavy. If you recall, top heavy means we have no horizontal asymptotes. Okay. And again, I'm getting these from, go back to those, our guidelines from our previous slide here. Okay. Moving on to our next example. Again, looking at our degree terms. In this case, they are the first terms in both the numerator and denominator. So this one, degree is 2 in the numerator, degree is 4 in the denominator, so this is bottom heavy. So if it's bottom heavy, it automatically is y equals 0. And then our last example, looking at our degrees, this is even. So we take the leading coefficients. So the leading coefficient in the numerator is 1. The leading coefficient in the denominator is 4. So our horizontal asymptote would be 1/4. And so this concludes our review of vertical and horizontal asymptotes. So we're going to apply this to what we've been doing in our previous sections in terms of graphing and sketching. So your bookwork that you're going to be working on will be really applying your rules to vertical and horizontal asymptotes in terms of your graphing. Okay, so again, this concludes our vertical and horizontal asymptote review.